this lecture, we are going to discuss about the Mechanical Translational System under Unit 1, Systems and their Representation of Control Systems. So before entering into the topic, let's recall the last class topic. In last class, we discussed about the open loop and closed loop control systems and some real-time examples of open loop and closed loop control systems. We know that an open loop system operates without feedback, whereas a closed loop system continuously compares the output with the input using feedback. Examples include a washing machine, timer for open loop, and air conditioner with temperature control for closed loop systems. So these ideas form the foundation for understanding mechanical system modeling. And today's topic for discussion is Introduction for a Mechanical Translational System and Ideal Elements of Mechanical Translational Systems, Free Body Diagrams and Applications of Mechanical Translation System. So now let's discuss about the Introduction to Mechanical Translation Systems. So for that, we are going to explore the DT empathize part of the Mechanical Translational System. So, a mechanical translation system is one in which all parts move in a straight line. So, unlike rotational systems, here the motion is linear and displacement is measured in meters. So, these systems are very important in control engineering because many physical systems such as elevators, vehicle suspensions, and machine tools exhibit a translational motion. Understanding this concept helps to drive mathematical models and transfer functions of real-time systems. So this is a mechanical translational system is one in which all parts move in a straight line. So now let's see about the ideal elements of mechanical translational systems. So the basic three elements of mechanical translation systems are mass, spring, and dashpot or damper. So what is a spring? A spring stores potential energy. The force developed by a spring is proportional to displacement according to Hooke's law. And we'll consider a mass. The mass resists changes in motion and stores kinetic energy. The force associated with mass is proportional to acceleration. The third one is damper or dashpot. A damper resists motion and dissipates energy in the form of heat. The damping force is proportional to velocity, not acceleration. So these three elements form the building blocks of any mathematical translational system. Now let's see about the quantity and standard symbol of mechanical ideal elements. So first discuss about the displacement. So the displacement standard symbol, we know that it is x and it is measured in meters. The second one is the velocity. It is v is equal to dx by dt. It is the unit is meter per second. The third one is acceleration. So acceleration a is equal to dv by dt. That is d square x by dt square. The unit is meter per second square. The applied force, it is represented by F and the unit is Newton. And the mechanical system having the opposing force and applied force also. So the opposing force offered by mass is inertia force, that is Fm. The unit is N. And the opposing force offered by a spring balance is represented as a Fk and the unit is N. Opposing force offered by a friction, that is damper or dashpot, that is Fb, N. The stiffness of the spring is K and Newton per meter. Viscous friction coefficient is B and Newton second per meter square. And the mass is M and it is in kg. Now let's move on to the free body diagrams of mechanical translational system. So in this, it covers the DT empathize part. So it is essential, free body diagram is very much essential for driving equations of motion and isolate each mass in the system and it is used to draw all forces acting on the mass, and it is used to choose a consistent coordinate system. So this is a modeling mechanical translation system. These are the basic three elements of mechanical translation systems: spring, masses, and dampers. And purpose of modeling of mechanical translation system: it is modeling mechanical system using differential equations. So it gives the dynamic behavior analysis, transfer functions, and system representation, analogous with electrical systems, and it is used to derive the control techniques and applications of the system. And now let's move on to the summarized part of this session. So in this session we discussed about the what is mechanical translation system and the basic elements of a mechanical translation system, that is mass, spring, and damper, and the units of a mechanical translation system with variables. Now let's move on to the curiosity challenge with a true or false rapid fire round. Spring force depends on displacement. It is a true or false? It is a true. Damping force depends on acceleration. It is a false one. So the learning outcome of this session is students are able to identify the basic elements of a mechanical translation system such as mass, spring, and damper. Now assessment session. The first one is which element in a mechanical translation system stores kinetic energy? That is a mass. And the force developed by a spring in translation system is proportional to, that is acceleration. And these are all the references. Thank you.